All right, this topic is essentially starting with operational amplifiers, but in order to understand operational amplifiers, there's a lot that you have to know before that. So it's kind of like telling a 5-year-old, all right, you're going to learn calculus. Well, before that happens, there's a few steps that have to go in between. So what do you need to know to understand an operational amplifier? Well, basically all of the electronical components, or a very large number of them. So we're going to talk about resistors, thermistor, LDRs, also known as photoresistors, variable resistors, diodes, cells, push switches, single pull, single throw switches, single pull, double throw switches, lamps, motors, LEDs, loudspeakers, buzzers, and capacitors. Then we get to operational amplifiers. So let's get started. A resistor, as we spoke about before, is a simple component that it's a passive component that that resists the flow of electricity. They have different ratings, and you can tell what the ratings are based on the color bands that are on the resistors. We spoke about that before on the IB test. As of last year, they provided you with the chart, so you don't have to memorize the chart of numbers, but you do have to know what the bands mean. The first band is the first digit, the second band is the second digit, and then if it's a 4-band thing, the third band is the multiplier, and the fourth band is the tolerance. Now, if it's a 5-band resistor, the first 3 bands are digits 1, 2, and 3, the fourth band is your multiplier, and the fifth band is the tolerance. Occasionally, 6-band resistors, the first 3 bands are the first 3 digits, fourth band is the multiplier, fifth band is the tolerance, and the sixth band is the temperature rating. You usually don't see those ones. This is the symbol for the resistor. It looks like the little up and down lines or a box. Either way, typically in diagrams it'll say R1, R2, R20, or it'll just have the value of the resistor written right above it. A thermistor, which is a type of resistor which is kind of like a thermal variable resistor. It is a resistor that has a variable resistance depending on the temperature that it's exposed to. The symbol looks like the one resistor symbol, but you have a hockey stick looking thing going through it. That's actually supposed to be representative of a graph with a temperature increase. Okay, so that's what that symbol really is. Now, there's lots of different types. All of these components really can come in different shapes and sizes. So just be aware of what they are. There's some examples on this slide. LDR, or light dependent resistor. I've always called them photoresistors, but they're basically the same thing. It is another variable resistor, but this time the resistance varies depending on the intensity of light. Okay, using any of these variable resistors, the thermistor and the LDR, you can actually make all sorts of sensors depending on what other electronics you put together. Now, the intensity of the light will cause this resistor to either increase or decrease in resistance. Now, the symbol for it is the resistor symbol with a circle around it and then 2 arrows pointed to that circle. Those 2 arrows represent light. You're going to see that in a few other components that have to do with lights. They come in a lot of shapes and sizes, but they look something like the image on the bottom right there. Variable resistor, also known as a potentiometer or a pot, is a type of resistor that is variable, but this time it's variable because there's a dial on it. Okay. In fact, there was one sitting in the back of the classroom right here. This is a potentiometer. The potentiometer right there, you have 3 pins on it, and the center pin is connected to a sweeper arm that goes around to the left or the right, and there's a ceramic ring on the inside. And as the sweeper arm, it touches the ceramic ring, so the amount of ceramic between 2 of those contact points, as that increases, the resistance increases. So this can also be used when you use just the middle one and one of the side ones. It's a variable resistor. If you use the middle one and both of the side ones, it's used as something called a voltage divider. Okay, very similar principle, but you probably don't have to worry about that one for the tests you're going to take. Okay. The symbol for a potentiometer or a variable resistor is the same old resistor symbol with an arrow pointed towards it. Okay, one arrow pointed towards it, not two arrows at an angle. Two arrows at an angle indicates light. A diode. You guys have heard of diodes. When you think of an LED, the D in LED stands for diode. But a diode is another class of component as opposed to a resistor. But a diode resists or doesn't resist the flow of electricity. It completely prevents the flow of electricity in one direction. So this property is called rectification. With a diode, electricity can pass only in one direction. Resistors, it can pass in both directions. Okay, a diode, it can only pass in one direction. So the symbol for it is the little triangle with pointing towards a line. Okay, the incoming or the tail end of the triangle, or rather the wider spot of the triangle, represents the anode. The anode, as we were talking about LEDs before, is where the electrons come in through the anode and they leave through the cathode. The line, the straight up and down line that's not that the triangle is pointed to, represents the cathode. There are many different shapes, sizes, and types of diodes: LED diodes, Zener diodes, all sorts of different types of diodes. Okay, but remember, resistors they're non-polarized. That means you can put them in any way. Okay, it doesn't matter what direction. A diode, there's a specific positive and a negative side. You cannot flip them around, or else they just won't work. Well, you can flip them around, and in some cases with LEDs, you can do something called multiplexing, where you can use a combination of resistors and LEDs and flip them back and forth and have them wired in a weird way, where you can use a limited number of output signals to control a large number of LEDs. A cell simply is something that moves electrons. It can be electrochemical, as in a battery. It can be photovoltaic, as in solar. There's a lot of ways that electrons can be impelled to move in one direction or another. The diagram for a cell is shown right here. You have long line, short line, long line, short line. Notice it's a even number of lines, which means one side is going to be long, one side is going to be short. A cell is a polarized component. In other words, there is a definite positive side and there's a definite negative side. Switches. You have what are called momentary switches or push button switches. This is a switch that is closed or sometimes open when it is held in, and then it changes state when you release it. So it's a button that you have to hold down for it to have a change in state. Okay, when I say open, that means off. When I say closed, that means on. So if it's normally open, that means the switch is not passing any electricity through it when it's not being pressed. When you press the switch and hold it in, it then goes to be, it closes, so then you have electricity flowing through it. That is a momentary switch. Now you have toggle switches, and the two types we're going to discuss here are single pole, single throw switches and single pole, double throw switches. Now a single pole, single throw is a simple on-off toggle switch. It controls a single circuit, and you have one flow of electricity. When the circuit is open, the electricity does not flow. When the circuit is closed, the electricity flows. On the other hand, a single pole double throw switch is a switch that doesn't switch between on and off, but it actually changes the flow of electricities from one circuit to another. Okay, so in this you can toggle between two active circuits. A lamp. A lamp is simply a device used to produce electricity or produce light from electricity. You probably already knew that one, though. In electronics, there's two symbols for lamps, although one is very rarely used these days. You have a lamp used as an indicator, which is the circle and an X through it, and then a lamp as a source of illumination, which looks like a Pokeball? I don't know. Anyway, it is a circle with a kind of a lump in the middle of it that's supposed to represent the filament. Now, when lamps are not used as indicators that much anymore, anyone want to take a guess as to why? Not because of sensors, because of a different piece of technology that's become increasingly popular over the past 20 years or so, and that's LEDs. Okay, LEDs are far more efficient in terms of electricity consumption. They last a lot longer, and there's a lot more, and they can be a lot brighter. Okay, depending on what you're doing. A motor is simply a device intended to produce motion from electricity. Do not call it an engine. An engine, and it's one of my pet peeves when kids call motors engines. They're not engines. Engines are something completely different. There's many different types of motors. Servo motors, stepper motors, brushless, linear motors, DC, all sorts of different designs. What we have here is an animation of a DC motor operation. This is taken off of Wikipedia. Basically, you have an armature that, in this case, you have an armature that's rotating around two magnets. This is called a rotor and stator combination. You have a stator magnet, which is a stationary magnet, and then you have a rotor that rotates. Now, the way the rotor rotates is, in this case, it is an electromagnet where the polarity is switched. On one side of the rotor, it's a north pole magnet. The other side is a south pole magnet, and the stators are fixed. So as the motor rotates, when it gets to a certain point, it switches polarity. The magnets switch polarity. So then it's pulled in the other direction. It's pulled. Momentum kind of carries it in one direction until it gets to a point where it's almost completely evened out, and then it switches again. So that is what allows the motor to rotate. An LED, also known as a light-emitting diode, is a diode that, guess what, emits light. It is the same symbol as a regular diode, but it has the two little arrows pointed away from it. That indicates that it is emitting light. LEDs, like all diodes, have an anode and a cathode, so they have to be connected in a specific way. There is a polarity to them. Standard LEDs have one anode and one cathode. Tricolor LEDs, RGB LEDs, they have a single anode and usually multiple cathodes, one cathode for each color. Okay, so an RGB would have one anode and then three cathodes, and each cathode would correspond to red, green, or blue. You can mix those by varying the amount of voltage that's coming out of each of those, or varying the amount of electricity that's flowing out of each of those cathodes. A loudspeaker and a buzzer, these are both devices that are designed to produce sound from electricity. Now, a buzzer uses a piezo electric material, as we talked about when we were discussing smart materials. It uses this piezoelectric. When voltage is applied across the piezoelectric, it changes shape. And if that voltage is pulsed at a very fast rate, you get sound. A loudspeaker uses a different method. It uses a driver coil. That is a coil that goes around typically a solid state magnet. So as that coil has electricity pulse through it, it moves back and forth, and that's attached to a cone, which causes sound to emanate. Oops. Yep, jumping around here. A capacitor is an electric device that basically stores DC electricity. Okay, so it will store the electricity in a material known as a dielectric. Again, some capacitors are polarized, some are not. The dielectric separates the two conductors, which normally prevents the flow of electricity. Let's explain more about that in the next one.